Welcome back. Today we're going to be studying 2.3 angles in a triangle. You're going to need your booklet, a ruler, definitely a compass, and an erasable pen or pencil. Got them? Great. Let's talk triangles. Please open up your booklet to 2.3. You're going to need this space right here. Now, you may recognize this diagram from the first page of the book. And let's take a moment to study it, see what we observe. Take a moment, hit pause. Write down 3 things you notice about this diagram. Got it? Great. Some of the things I notice is we have a pair of parallel lines. We have a triangle shape here. We have matching alternate interior angles here and here, as well as another set of alternate interior angles here and here. So what we're about to prove is a fact that you were taught in middle school, but you were never taught why it's the case. We're about to prove why all 3 interior angles of a triangle are always the same measure as a half circle. Let's take a look at how to do that. On the other side, let's start by just drawing a base. We're going to replicate this diagram right here. So draw a baseline. Now I want to make another line parallel to this through a point. So I'm going to draw a point right here. And in order to do that, I'm going to take advantage of the fact that if parallel lines of 2 lines are parallel, then alternate angles are congruent. And I'm going to say, well, you know what? Through this point, I'm going to draw an angle. And then I'm going to copy this angle right here. I'm going to just show you like this angle right here. I'm going to copy this angle right up here so I can create a parallel line through that same point. So taking my handy dandy compass, I'm going to put the point on the vertex. I'm going to mark 2 points equidistant from each other, and then I'm going to measure, like right there. So that's kind of like a reference point. And then I'm going to copy that same arc and feel comfortable turning your book to whatever angle makes it comfortable for you over here. Then I'm going to measure how wide open is my angle at that reference point. Try and be as precise as you can. Then copy that angle over here. Now notice I didn't draw my reference line all the way over, and that's not a problem because I can still open it, remeasure whatever my reference line was, and draw it in. That point right there, that's the second line of my parallel. So line up the 2. Take your time. And there's my parallel line. Then, using my ruler, I'm going to finish this triangle to create a copy of this diagram right here. Now, how do I then say that angle A, B, and C equal 180? Well, let me think about what I know. I know that this angle and this angle have to be congruent because they're alternate interior angles. So I can say, well, let's see, A and A is congruent. I can also say the same for this one, where this angle, marked in green, is the same as this angle, also marked in green. These also have to be congruent. So, if A plus B plus C equals 180 when you put them in a straight line, then they must equal, or rather sum, because equal means itself is equal, must add to 180 under all cases. Remember, I don't even know what A, B, and C are, but I know that the geometry of the situation always will show me that. We can then use the fact that all these different angles add to 180 in a whole variety of different problems as we're about to. But before we do that, I'd like to introduce you to one other language. One, inside of a triangle, these are called interior angles, like inside. If I extend the baseline and do a reflex to that baseline, that's called an exterior angle. So 30, the interior angle and exterior angle will always add up to 180. And there's some advantages to knowing that fact as well. Like, for example, when I take a look at this diagram right here, I want to find the measures of A, B, and B in the figure to the right. Justify your results. So I'm looking at this right here, and it's like, oh boy, where do I even start? Well, one thing I know is these three angles will add to 180. I also know whatever's here is the linear pair of 69. So I can find this angle and this angle as well. If I can find those two angles, well, I can find B because this angle is 100 and this forms one complete triangle. And once I can find B, I can find A. Now, this is not the only way of solving it. It just happens to be one way. Now, thinking about what we have here, let's take a moment. Let's see, 93 plus 68, so feel comfortable doing scratch on the side. 93 plus 68, 58, 9 and 5 is 10 and 4, that's 140. 3 and 8 is 11, so that's 151. So if this was 180 minus 151, that would be 30, but it's not, so this is 29 degrees. This is 69. 180 minus 70 is 110, so this is going to be 109, which means to make this add up B to 180, let's see, 109 and 29 is really close to 110 and 30. Well, that's 140, so this will be 2 less than that, or 138. Well, 140 to get to 180, that would have to be 40. So 138 to get to 180, I would need to add 42. So B is equal to 42 degrees because the angles of a triangle add to 180 degrees. Similarly, since I now know that this is 29 and this is 58, well, 29 and 58, I can think about it almost as 30 is 58. That would be just 88. So this has to be one less than that, or 87. So let's see. If that's 87 and 42, that's 12 and 9. So that's almost 130. And 130 to 180, that would be 51. I'm sorry, that would be 50. So 129 to 130 plus 1 plus 50. That means A is what's left over, or 51 degrees. I want to explore one more problem with you because this is actually a really critical skill. One thing I want you to notice is that when we have in each figure determine the measures of the unknown labeled angles, give reasons for your calculations. I know this angle right here is unknown, right? But I do know this unknown angle adds to 78 to make 180. I also know that same unknown angle, so unknown angle plus 78 equals 180. I also know that same unknown angle plus A plus 42 also equals 180. So I could say for a moment that when I add 78 to the unknown angle, I get 180. And if I add A plus 42 to 180, I get the unknown angle. I could say, therefore, the unknown angle can almost like be canceled out of the problem. And say, well, 78 minus A plus 42 is 0. When you have something minus something and it gives 0, that means these two things are identical. So A plus 42 equals 78. That makes this question a lot easier to solve. If I take away 42 from both sides, let's see, 70 minus 40 is 30. 8 minus 2 is 6. That means A is 36 degrees. This is something we're going to later prove as we continue through this unit, but it's a fantastic trick, for example, when you get to number 6. Looking forward to talking with you about this in class. Have a wonderful rest of your day.